Hey, Plumber Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of Mathematics for Plumbers and Pipefitters. My name is Thomas, and in this presentation we are looking at Unit 16, which is Angles in Plumbing. In order to understand angles, we have to start with a circle. And a circle is something that's very common to a plumber because we deal with a lot of pipes that are shaped like a circle. And we deal with fittings that are created from angles of a circle. But that's exactly what we're going to look at in this presentation. What is an angle? And how do we come up with that? Let's start with the basics of a circle. What is a circle? Well, you and I can create a circle using a compass by having a fixed point and moving that compass all the way around from where it starts, coming all the way around back to where you started. That creates a circle. But as we look at angles, how did we get to these different numbers for angles? And who came up with 360 degrees equals a circle? Well, a quick Google search reveals that this actually came from the Babylonians 2,000 years ago. Imagine it like this. If you can create a circle and want to divide that up so that you can talk to other people about a portion of that circle, how would you divide it up? Well, you'd probably start by drawing a circle and then cutting it in half, put a line down the middle. And then you might do it the other way, perpendicular, and now you have quarters. And maybe you do that some more and you have sixths or eighths. However you end up dividing that up, the more lines you put across there from the edges through the center point to the other edge, you're going to have more and more divisions of that circle. And so as the Babylonians considered a circle, they looked at it and said, well, what is a number that you can divide up really easily? Some numbers can be divided into smaller portions. They call them integers, the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. They can be divided up by those integers more than others. And they found that the number 360 can be easily divided into smaller portions by every number except for the number 7. You just have to know the number 7 is a weird number. It's not divisible itself. It gets cut into decimal messes. So they said, let's just ignore 7. But you can divide 360 by 2, and you get 180. You can divide it by 3, and you get 120. You can divide it by 4, and you get 90. And so on. All the way up to 9. You can divide it into 9 pieces. And it still comes out evenly. So they said, this is a great number to use as we're dividing up a circle and trying to decide how to describe smaller portions. And these divisions that were created are also what created angles. That brings us to Unit 16's topic, which is angles in plumbing. If we have a look at this, we're going to have a look at this half circle diagram that they have in Unit 16, and you can see the divisions we were talking about if you're creating a cross line through the circle. And the way we refer to these smaller divisions of the circle is degrees. So you can see on here we have a 90 degree. We could cut that in half. There's a 45 degree. But this diagram shows us a variety of degrees that are commonly used, or maybe some of them less commonly used, for the fittings that we install. Now these fittings allow us to change the direction of the pipe by a certain degree of angle, right? We're sending the pipe to a different place. A couple of interesting notes here from the book. Smaller pipes, that's 1.25 inches and smaller, for the most part, only have 90 and 45 degree fittings. But when you get into larger pipe sizes, now think drainage, 1.5 inch pipe, 2-inch pipe, 3-inch pipe, and bigger, you can buy 60 degree fittings. You can buy 22.5 degree fittings, And they do apparently make 11 1/4. I've never dealt with one. And apparently in cast iron they make 72 degree fittings, but no 11 1/4 degree fittings. But this really kind of narrows it down to the degree of fittings that we commonly use as plumbers. Okay, follow me here on the diagram as I read this description that's right here in the text. It says a fitting angle, and they abbreviate that FA, is measured between an extension of one center line to the other center line. So you'll note here I've highlighted 2 center lines, and the distance between them is what creates the angle. The larger the fitting angle, the greater the angle of measure. So fitting angle is a term referring to the actual pipe fittings that we use and the angles that they create. Further in the unit, we find a diagram of a fitting, and you can see some lines on here. The FA, as we talked about, is the angle of the fitting. But there is also what is called a complementary angle. The text says a complementary angle, abbreviated CA, is often mistaken for a fitting angle. The complementary angle is found by subtracting the fitting angle from 90, or 90 degrees. The larger fitting angle and the smaller complementary angle equal 90 together. So here we have an example of that. The complementary angle equals 90 minus the fitting angle. So the complementary angle equals 90 minus, in this case, it's a 60 degree. The fitting angle is 60. So the complementary angle left over is a 30 degree angle. Let's have a look at another term that is commonly used by plumbers and suppliers and manufacturers as we refer to fittings, and that is by the bend. They'll call it a bend. Maybe you've heard a quarter bend, an eighth bend. How do we come up with that? Well, a bend is a fraction of a circle. And when we say circle, remember we're talking about 360 degrees. So in order to find this fraction of the circle, we're going to take the fitting angle and divide it by 360. And that will give us the bend. So in this case, if we have a 60 degree angle fitting, the bend would equal 60 divided by 360, and that's a fraction. I mean, if you throw that in a calculator, you're going to get a decimal. But we can reduce that fraction. 60 goes into 360 6 times. So that gives us a fraction of 1/6. And 1/6 is what we would call the bend. So we would say I need a 1/6 bend of 3 inch or whatever. This is how we come up with bends. Many times if you look on the boxes of a fitting, they will refer to them as a quarter bend or an eighth bend. And we're just dealing with this. It's referring to that fraction of a circle. So let's say that I have my bend, but I don't know what that fitting angle is. There is a way that you can calculate the fitting angle from the bend, and here it is. A fitting angle equals the bend times 360. We're basically reversing what we just did in order to find the bend. So if we say fitting angle equals 1/6 times 360, that's the same as dividing by 6, but we end up with the fitting angle equals 60. Now you can do this with any of the bends that you may run into. Consider, for example, a quarter bend. 1/4 times 360 equals a 90. 90 degrees. There we go. All right, that completes our explanation of Unit 16. And now it's your turn. You can get in and do some of these exercises. These exercises are going to take you back through the formulas that we talked about in here to calculate fitting angle or bend. So if you have any questions, just look back through the book. You'll find right there in Unit 16 the formulas that you need, and you can calculate those out. And I will see you in Unit 17.